Hello, my friends of Lab. My name is Montoya. Please have a nice afternoon. Now we are going to talk about a tutorial of geochemical simulation tutorial of water mixing in Phreeqc. So this tutorial is related to the example number 3 of the Phreeqc documentation, where you have the mixture in between pure water at equilibrium with calcite and seawater. Yep. Um, and then you have three cases. You have pure water at equilibrium with calcite, you have seawater, and then you have the two solution mixed, 70% of water and 30% of seawater. And then you have the mixture but equilibrated with calcite and dolomite. And then you have the mixture equilibrated only with calcite, calcite. Well, okay, because the chemical evolution of the dolomite precipitation is negligible. Okay, so we are going to start. Okay, for this tutorial, what you will need is Notepad with Phreeqc. We have already done a tutorial on that. So I'm going to open a new Notepad, and then I'm going to close my other documents. Cool. And then, first of all, we are going to define the part A, that is the calcite equilibrium with pressure of CO2 at -2 and 25 degrees. And then here we have the solution. This is pure water. This is what will actually go into the reaction. And then we simulate equilibrium phases where the pressure of CO2 is -2 and calcite is an equilibrium. Okay? And then we save that as a solution 1. Okay? Actually, you don't see this as a Phreeqc file because you need to save it first. I mean, the format is not ideal because it's like any other text file because we need to save. So save as, and then we say water mixing 3. You will receive these files as well. Okay? And then when you save it as PHR, then you see it recognizes the keywords of Phreeqc. Okay. After that, we will write the second solution, that is seawater. Seawater as well will come with units in parts per million, pH of 8.22, and concentration, since this seawater, of chloride and sodium. Okay, and important concentration of magnesium as well. Okay, and then we are going to define the part C, that is the mix, because there is a mix in between 70% water and 30% seawater. Okay, so here we have the mix in between 70% of the solution 1 and 30% of solution 2. Okay, cool. Yep. If you have seen, this is solution 1 that, I mean, maybe you have this, maybe you confused with this. This is solution 1 that goes into the reaction of equilibrium with calcite, and then the output is solution 1. Yeah, and then here you have the solution 2, that is actually seawater, and then you have the mixture in between 1, but it's this one, and 2, that is this one. Okay, cool, great. And then you have the equilibrium mixture of calcite and dolomite. I mean, the solution, but the equilibrium of calcite and dolomite. What does it mean, equilibrium? That the solution is not subsaturated and it's not oversaturated with calcite, so it's at equilibrium. Okay. Okay. And then we have the equilibrium with, but just with calcite. Okay, because in this case, it is known that dolomite precipitation, the kinetic of the reaction is really, really low. That's why it is assumed that only calcite is at equilibrium, while dolomite can be oversaturated or subsaturated. Okay, cool, great. And then we save it, and then we save it as save as. We save that with the that extension. Okay, we save it, and then we run it. Run Phreeqc file, and it has run. So this is our input file, and this is our output file. Okay, I have prepared a, say, a table here where we are going to put for case A, which is the pH, the saturation index of, of CO2, calcite, dolomite, and this is which is the mole transfer of all of them. So let's go first to the first solution on the out. Cool. So here in solution A, okay, here on solution A, the pH is 7.297. The saturation index of CO2 is -2. The saturation index of calcite is 0 because it's at equilibrium, yes. Of dolomite is nothing because it's not defined. Yeah. And the mole transfer of CO2 is minus. That is actually, that's called, what does it mean that is minus? Is that actually goes, that some of the CO2 that comes in through, from the air is diluted in water. Okay, that's called the minus. And from calcite is some of the calcite that is on the solids, on the medium, is as well diluted because it's minus. When the mole transfer has a positive sign, it means that it's precipitated. Okay? So, and this is diluted. Okay? And of dolomite, no, we don't have stated that yet. Okay, cool. This is for solution A. And then for seawater, for seawater, we will have our material where, I mean, the pH that we have stated, pressure of CO2 is, salute. Pressure of CO2 let me check what is the partial pressure of CO2. Okay, the partial is minus 3039, so minus 0.39. Okay, the saturation index of calcite is 0.75. So what does it mean? That is oversaturated with calcite. And from dolomite is 2.39. So what this means that seawater is full of calcite and dolomite, and most probably it will precipitate. But since our reaction we haven't inserted any equilibrium phases, it won't precipitate. Okay, cool. And then this is seawater, this one, and this is pure water at equilibrium with calcite. Calcite, calcite, calcite. Wait, later you tell me. Okay, and then we have the the mixture. The mixture is solution 3. I mean, is part C, where we have the mixture. Yep. And on the mixture, we have a pH of 7.39349. Okay, cool. That's great. Then we have the pressure of CO2 of 2.23. Yeah, the saturation index of calcite is minus 0.1. What does it mean? That is under the mixture in between the two of them is undersaturated of calcite. Okay, subsaturated of calcite, and then of the dolomite is 0.52, and the mixture is oversaturated of dolomite. But since we have already stayed, no, this is only the mixture, because this is only the mixture and there is no equilibrium phases here, so the minerals cannot precipitate and cannot be diluted. No? But what we see that is oversaturated in dolomite. So what does it mean? That when we insert some equilibrium phases, it will precipitate and is undersaturated of calcite. What does it mean? That it will dilute the calcite. Okay. And then the third, the third case. No, that will be the fourth case is, okay, when we have part D equilibrated with calcium and dolomite. So this is the pH of pH is even lower. And then the pressure of CO2 is minus 1.98. Yeah? And then the saturation index of calcite is 0 because it's at equilibrium with dolomite, with calcite, and as well 0 as the equilibrium dolomite. Since we have already said that it's at equilibrium, we will see if those minerals have precipitated or have been diluted. Okay, so let's see. Let's go to this part, that is the phase assemblage, and say that of calcite, we have that final is this one. So what the, yep, so it means that 0.015 mole have been diluted, okay? And this is from calcite, and from dolomite, this amount of moles have been precipitated. Okay? Okay, so these have been diluted of calcite because it's subsaturated, and this one will be precipitated because it's oversaturated. Okay, then uh, what comes from the research, from the field research, is that dolomite precipitation is a very slow kinetic reaction. So mostly it won't happen. I mean, it doesn't matter if the reaction is oversaturated with dolomite, it won't precipitate in comparison with the rate of the calcite. So what do we do here? So that's why we have simulated this, but just in equilibrium with calcite. So this is the pH is 7.044, and the pressure of CO2 is minus 2.31. The saturation index of calcite is 0 because it's at equilibrium, but the dolomite is not in equilibrium. Let's see how is the saturation index of dolomite. It has to be saturated, 0.72. Okay, the mole transfer of CO2 is here. The mole transfer is says that some of the some of the some of calcite that is on the media will be diluted into the water. Okay, while calcite, okay, sorry, here, and let's see how is the saturation index of CO2. Cool. Oh, sorry. I made a mistake here. These ones are here. Okay. Okay. Great. So what we do have here? At the beginning, pure water is at equilibrium with calcite, and there is some CO2 and calcite that are diluted into the water. Then you have the seawater. This is seawater. Seawater is actually uh, oversaturated with dolomite and calcite, but when you mix it with water, it's actually oversaturated in dolomite but subsaturated in calcite. Okay, and then on the last, this is oversaturated. But if you say that this is an equilibrium with dolomite and calcite, uh, some of the some of the calcite will be diluted, and some dolomite will be precipitated. Okay, but since we know that the precipitation dolomite is a reaction that will take a lot of time, some of the and it means that water can be oversaturated with dolomite and nothing will happen. Yeah, while it can be in equilibrium with calcite, and in that case, some calcite is diluted. Okay, cool. That was a really interesting and practical example uh, of Phreeqc, and I hope that you have enjoyed this example. And we stand for, we are Qatari Labs. We are a blog for knowledge sharing of open source software in water resources. Yep. We have a blog where we have a lot of tutorials, so I strongly recommend you that you follow us by our bulletin and as well as by our newspaper. yeah, newsletter. Yeah, we are producing a lot of tutorials, and we have as well as a Facebook account. So I also recommend you that you follow us on Facebook and on Twitter, and we are going to provide even more tutorials about groundwater modeling, Phreeqc modeling, and another open source software that are on the market. Okay, my name is Saul Montoya. Please follow our website, and on the future we will have as well online courses here. Right now we don't have, and then you can drop us any questions through our contact form here. Okay. So again, my name is Saul Montoya. Please have a nice evening or nice afternoon, and I hope to see you in another tutorial. Please subscribe to this YouTube channel as well. See you. Bye bye.